Hello everyone, today I'm going to show you how you can calculate area of sloped glazing roof inside of your Revit project. As you can see, I have here my sloped glazing roof, which I'm using for a ceiling. You can use this very well for example, these acoustic baffles for the ceiling and model them. But now I need to schedule the area. So if I will go to schedule and create new roof schedule, and go with my family and type and my area, you will notice that out of the box Revit is not able to schedule area for sloped glazing type of roofs. As you can see, the area parameter is empty, and even if I go into my Revit project, if I select the area, you can see that there is actually no area parameter in here. So what I need to do is to use Dynamo to be able to obtain this data and pass it back into my sloped glazing roof. So we are going to do this now. We will go into the manage and into the Dynamo, and we will open the Dynamo, and we will open a new blank workspace. Now inside of the Dynamo, we need to first select the model element to be able to get the data from. So we will go with the select model element. Just drop it onto the canvas, and now we will select the element inside of our Revit project. And now if I go back to my Dynamo and I run the script, you can see this is our footprint roof. Okay, so now we need to get the sketch of this roof, which is basically these outlines that you are using to draw the boundaries of the sloped glazing. So we need to obtain these curves to be able to calculate the area. So back to our Dynamo, we will go with the node sketch. This one from Springs. Springs is a package that you can download in the package manager. And what this node does is that if we pass an element that is sketch based into it, if I run it now, you can see that we will obtain these curves, these lines. And if we will check this in our background preview, you can see these are the sketch lines of our roof by footprint. So okay, now we need to create a polycurve from this, because from the polycurve we can create a surface, and from the surface we can actually obtain the area. So we will go with the polycurve. And we want to go with the polycurve by joint curves. And we will pass all of these curves into this node. And now if we run it, we will get one closed polycurve. As you can see, it has number of curves, which is 6, which is the same as the number of these lines we are passing into the polycurve. So now this is one big closed polycurve, and we can now use this polycurve to create a surface from it. So it is called surface patch. This one, surface by patch. Now if I run this, you can see we have created a surface, and from the surface we can get an area. If we go to the surface and go with the area, now you can see if I run this, we get a really huge number, and that is because my units are millimeters, so this number is in millimeters squared. So we need to convert this into the meters squared. So we will go with our convert units. So this one, convert by units. And we know that we want to go with the area. So we will find our area in here, and we go with like from square millimeters to square meters. And if I pass this number now into this, you can see that now we have a number in meters squared. So this is 167 point something. Now what we need to do with this number is pass it back into our Revit project. And for this I have created a custom shared parameter if we go back to our Revit now, you can see in my sloped glazing roof, I have this parameter called R area, which is my custom parameter of the type area. And now it is with the 0 value, but we will pass this number we have calculated inside of our Dynamo script into this value, and we can then use this in our schedule. It has to be shared parameter for you to be able to use it in schedule. So we need to write this back into our element. So we go with the set parameter by name, and the value is this one. So we will just connect it. Element is the same element that we have used to get the data from and to calculate the area. So this will be this one. And the parameter name, we need to go with the string input. And the parameter name in my case is called R area. And now if I run this, you can see that it was able to write it inside of my roof by footprint. And if I go back to Revit, and you can see now that my sloped glazing in Revit has now 167 point something meters squared of the area inside of this custom parameter. Now I can go to my roof schedule and add my custom parameter in here. So I will go with my R area, and I can go with this area back. And now you can see that I'm able to schedule area for sloped glazing roof inside of my Revit project. So this was really easy script where you just select one element and you get the area, but it was just like to show you the concepts, how you can do this, and you can modify this script to actually collect all of the roofs of the same type from the project and write it into the parameter at the same time, and so on.